Okay, today we are going to discuss the one sample t-test again. But today we focus on the test statistic. So in step number 2, the test statistic was the t-score, and we used the sample mean because we focused on the population mean. So we take a statistic, sample mean from the sample, and compare to the initial setting value, and then divided by the standard error. So today, I want to explain to you, I want to remind you how can we get the test statistic, okay? Okay, so before the t-score, we have to remind something. Can you remember what was the Z for? It is a universal symbol in statistics for a standard normal distribution, right? So it is a standard, it's a normal distribution. So it is a very special normal distribution when we have zero mean and standard deviation 1. So always the normal distribution looks like the bell shape, but especially the mean equals 0 and the standard deviation equal 1. I mean the standard deviation means the variation, that is number 1, and the center is equal to 0. So that was the standard normal distribution, and we use the Z. And when we have any kind of normal distribution, let me say X, right? So let me say X is a non-standard normal distribution. Can you remember how can we standardize non-standard normal distribution?
Approximation. Can we use
Yes, but we have to do something. For example, look at this one. Here's a 0. No, not there. Let me say here. Here's a 0. And we have any kind of normal distribution here. Let me say the X here, right? And probably the mean is not equal to 0. And the standard deviation is not equal to 1. Okay, so any kind of normal distribution X is here. The standardized means we can make a standard normal distribution. So it's actually the green one is a Z, the standard normal distribution. How? First, we have to move to here. You know, before the center was the mu. But if I want to make the standard normal distribution, then we have to make the mean is equal to 0. How? I simply just take off the mean, then it will be the mean equals 0, right? That means when I have a score on the mean minus the mean minus the mean will be 0. Right? It's here. If I have any score is bigger than mean, the score, the value minus the mean, that will be a little bit bigger than 0. How about a little bit less than? A little bit less than the mean. Minus the mean mu, that will be is here, right? So when I had a non-standard normal distribution here, but simply take off the mean, then we can relocate we move to the mean, mean 0. Okay? But you know the standard normal, it is a distribution. So it's not only 0 in the middle, but also some scores can be positive, some scores can be negative, right? Yeah. So simply just take off, simply subtraction the mean, then we can move to the left and place at 0 center, right? But now we can adjust the size because before the x normal distribution doesn't have the standard deviation is equal to 1. So now it's not only subtraction the mean, but also we can divide it by the standard deviation. So it's not only subtraction the mean, but also divided by the standard deviation. Then now we can standardize the normal distribution. So can you remember this one? Yeah, in step number 1 is many times, yeah, we took the z-score in that way. Take off the mean divided by the standard deviation. Good, right? Can you remember this one, this formula, this ratio? Then now, it's here. Then now, let me give you the sampling distribution. Because in the test statistic, we use the X bar. X bar, it was the sample mean. So let me remind you what was the sampling distribution for the sample mean. Sampling distribution of sample mean, which was the normal distribution. It was the normal distribution. Always the normal distribution need another mean and another standard deviation. Can you remember what was the mean of the mean? I mean the average of the sample mean. Do you remember the CLT? Can you remember what stands for the CLT? C, central, L, limit, T, theorem. CLT. By the CLT, central limit theorem, the mean in the normal distribution for the sample mean was mu. Who was the mu here? It is the population mean. Definitely, we don't know what is the population mean. That was the reason why we are testing. In step number 1, initially, in the null hypothesis, we suspected unknown mu, the mu, was equal to mu 0, right? But anyway, even though we don't know how much is the mu, but by the central limit theorem, the mean in the normal distribution for the sample mean is the mu, the unknown population mean. And how about the standard deviation? You know the second part in the normal distribution is another standard deviation in the normal distribution for the sample mean again, which was the sigma over square root of it. Can you remember one by one? Please trying to remind, one by one, okay? What was the mu? The mu was, just a second. Let me change the color. The mu, it is the population mean. Sigma, it is a population standard deviation. How about the n? Who is the n? Sample size. Thank you. You know, it is a normal distribution for a sample mean. It's actually the sample mean from the sample. It's based on n sample size. So we need the population mean, we need the population standard deviation, and the sample size. We can determine the sampling distribution of the sample mean. It is a normal distribution. So far, so good, right? Okay, now let me standardize. Here. This way, we can standardize the sample mean. Before I told you this way, this formula, we standardized x because x was non-standard normal distribution. So this way, we standardized non-standard normal distribution x. But what I want to do now, I want to do standardize the sample mean. So let me plug the sample mean here because we want to standardize the sample mean. Then what? Take off the mean. How much was the mean? Mu. It's actually the mu was unknown population mean. Then what? Divided by, here was a sigma, because the sigma was the standard deviation. But now, we have to divide it by our standard deviation in the normal distribution, which was sigma over square root of it. So, exactly same way, we plug the target sample mean, which we want to standardize, yeah, the very first one, and take off its mean, and then divide it by its standard deviation. To get what? The z. Now we can take the z. Okay? So let me show you all of them together. Look at this. The very beginning, we discussed how can we standardize. Second, we discussed the sampling distribution of the sample mean. So now, we standardize the sample mean exactly this way. Please compare to the test statistic in one-sample t-test. What's the difference? First, here's a mu 0, but here's a mu. Just a second. Where was the mu 0? Actually the mu, it was unknown, let me say it's unknown, population mean. That was the reason in step number 1, is step number 1, in the null, we suspected unknown population mean was equal to our initial setting value. So now, in the z-score, The mu is actually, the mu here is the same as this one, was unknown. But the test statistic t-score is actually, it was in the second step. Before the test statistic, we stated unknown population mean was the mu zero. So now we can plug the mu zero here. You know the step number 1, step number 2, 3, 4, and 5, it is a steps, procedures. So very beginning, we assumed, we stated unknown population mean was the mu zero. So now we can plug the mu zero here. And also sigma. What is a sigma? Population standard deviation. It's not only the mu, but also another Greek letter, sigma, was in the population. What does it mean? We don't know either. Even the sigma, the population standard deviation in the population, unknown. How can I do in statistics? He said estimate, right? Yeah. So whenever we don't know something, always we can estimate. We estimate the sigma, unknown sigma, with the S. What is the S? Sample standard deviation. But you know the N is a sample size. It's actually the sample size from the sample. It's one of the statistics, right? We knew it. So just plug the N here. Okay, now please look at the T. Let me write the T. It's a bigger here. It's a T here. X bar minus mu zero S over square root of it. Let me erase the left-hand side. So please compare. Please compare the right-hand side of the Z and the right-hand side of the T. It is almost the same, but we replace the mu zero to the mu, unknown population mean, and also we estimated unknown population standard deviation sigma with the S. But it looks similar, but it's a totally different one, right? So the first one, it was a Z, but now the second one is a little bit different. So now we named it is a T. You know the Z standard normal distribution and the T distribution looks the same. Both of them is a bell shape, mean equals 0. But the T distribution, even though it has a mean equals 0, but we don't need the standard deviation. But instead of the standard deviation, we got a degree of freedom. Can you remember the degree of freedom? Now, in the one-sample t-test, the degree of freedom was n minus 1. What was the n? Sample size. Yes, it is a sample size. The reason why the degree of freedom is equal to n minus 1 because we use the S. We use the S as an estimation of the sigma. The S had the degree of freedom n minus 1. So we just copy the degree of freedom from S. That would be same as the degree of freedom for the t-distribution. Okay, so when you're trying to understand the one-sample t-test, right? Yeah, it is easy. It is easy to apply the one-sample t-test by 5 steps, but please try to understand how can we get the test statistic t-score, right? Actually, it was from the standardization, from the standard normal distribution. How can we standardize any kind of normal distribution? But we can apply the standardization as onto the sampling distribution of the sample mean. So it's actually, we can take the z-score. We can take the z-score here. It was the standardization of the sample mean. Take off the mean of the mean and then divide it by the standard deviation of the mean. And then we can estimate, replace unknown parameters. The mu, population mean, sigma, population standard deviation, they are all unknown. So practically, we can estimate it, replace them to get the test statistic, but now it is not standard normal distribution anymore. So we have to apply is another distribution. That was the t-distribution. Okay, yeah. So please trying to understand how can we get the t-score? How can we get the test statistic in one-sample t-test? Sorry.